Hello and welcome to my presentation here about TextMinR, integrating AI in literature and media education. My name is Alexandra Pusicani, and this is a joint work with my colleague Dominique Doreschal, who also works at TGM Vienna with me. So our goals for this paper presentation for our project were to empower natural language education through using NLP methods. To this end, we provided different access to machine learning and artificial intelligence methods, which, unlike the overwhelmingly present generative AI algorithms, are meant to lay an understandable basis for critical discussions and evaluations of such algorithms based on something which is basically undoable for humans reading hundreds and thousands or millions of literature data. Therefore, we also wanted to use this project as a method of teaching interested and talented students hands-on skills in AI and text mining through actively working in this project. In this sense, we wanted to use this project-based learning as a method to teach them planning, interacting, collaborating in such a software development project, which reached over 8 months as a whole, and this was meant for fostering their problem-solving skills as well as making them take responsibility and teaching them relevant skills for the 21st century. So what's NLP? Natural language processing is a subfield of artificial intelligence research, which focuses on the interaction between computers and the human language. It aims to enable computers to understand, interpret, and generate human language in a way that is both meaningful and useful. There are many ways of doing that. Sentiment analysis, chatbots have been around for a long while. Also, text summarization is something very familiar, what people are very familiar with. Automatic language translation is also something we've been using for years now, and GPTs, generative pre-trained transformers, are something rather new, which have become super present in the latest year through their outstanding performance and availability. However, we will focus on two different aspects. One of them is topic modeling, which is a bit lower down than these neural network algorithms. And one is named entity recognition, which is building on GPT algorithms for performing pre-specified tasks. So, project-based learning is the didactical background for what we want to use here as our instructional approach, because it engages students in hands-on and real-world problems through these projects, and therefore forces them to apply critical thinking, problem-solving skills, and naturally, because it's too large for one person to manage, they have to collaborate and apply their different degrees of knowledge in order to solve this very complex challenge from a student's perspective. Therefore, these project-based learning approaches have been included in Austrian curricula for decades, at least for vocational schools, because there always a group of students has to work together on a diploma thesis. This is always structured in part where one student has one clearly predefined task to fulfill. And in addition, one of them becomes the project leader and coordinator who keeps the whole group together and manages that everything becomes a totally useful project, and in the end they can wrap everything up into a single thesis. Therefore, they all work on their separate parts, which differ theory and implementation, because on the one hand, it's still school, they should learn about some theoretical backgrounds. On the other hand, they are meant to implement them for managing to make this project actually work. Therefore, they also have to plan goals already at the beginning of these projects and create a timeline with milestones, which should be reasonable enough to reach, teaching them how to split up such larger projects, which are not a single few hours homework they are usually working on. Therefore, the documentation of these different parts is also a relevant part of their evaluation and is joined together in order to form their thesis, and which will then be presented in the end and for which they have to go through an examination. This leads us to our research question. So, how far is it possible that we can teach vocational high school students at the age of 18 to 20 the basics of machine learning, natural language processing, and app development through such project-based learning approaches? And the second research question is, how can a web-based application developed to visualize and interactively experience the German and English language using a Shiny app be useful for teaching and learning languages and literature? So, our approach is classical agile project management approach. So typically they don't start from zero. We work with them on a kind of prototype in the year before. This is also what happened here, and based on this we were able to plan this ahead for the project which was managed here, and during the implementation, reviewing what they actually have managed or what went wrong, they, in retrospect, had to adapt their plans, making this agile as opposed to predefined, which led to a prototype which was workable enough to perform usability tests. And these were also included to improve our program to end up with a final prototype. Our usability tests, which I just mentioned, were designed of two phases. One was a pre-test questionnaire, the other the post-test questionnaire. And in between, our language teachers who helped and supported us in this project were asked to work on 6 different tasks, which was creating a word cloud, getting informed about the trend graphs, generating a trend graph, creating a map diagram, modifying this map diagram, and modifying the trend graph. So I will show you several things later on when I talk about the visualizations. And then we asked people how they actually felt about these, the usability of this, handling this software and this graph. So how is this whole thing implemented in the first place? Our front end is our Shiny app, while the core of this whole thing is an Elasticsearch database. Our data stems from 3 different sources. On the one hand, we have Project Gutenberg, which is accessed through the API Gutendex. On the other hand, we have web scraping of news articles, publicly available by a lot of news media. And as the third part, we use personally uploaded texts provided by our users. So there's this API, which then does the data collection from our data bank and then has to format this whole data in order to then pass it on to the UMAP, which will reduce the dimensions, because we're talking about hundreds of thousands to millions of dimensions, because basically each word means a different dimension. Once we have that, this is clustered by an HDB scan. And when then we have reduced it a lot in dimension and find which parts of documents join together reasonably, we pass it on to this CTF IDF for actual topic extraction. Once we have these topics available, there is an automatic topic labeling step happening. This topic labeling step has manual data labeling as its basis, which means that once we have these labeled topics as the ground level for starting, we then do a data augmentation and use for this GPT to have these labeled topics with the top 10 to 30 words and create new such data sets in order to fine-tune pre-trained large language models, such as a T5 model, which then will learn how to use these top relevant terms of topics in order to label the topics. So this is the automatic labeling part. One of our students trained these things. And this is how this then looks like. So here are, based on 2 different metrics, 5 terms each, in order to show that in many cases this doesn't make such a difference which kind of term you use. In other cases, this makes a huge difference because there are some words which change completely whether you use one or the other metric for including them in the top 5, which is why we wanted to extend it to at least the top 30, because this is more robust with respect to these things. And this then was the basis for showing different types of labeled topics. So an alternative of showing these top relevant words is using word clouds. People are very familiar with that, especially from the language teaching perspective. And therefore, we also included this not only in our prototype, but also in our final version. One of our basic things is our topic models, which are represented in a scatter plot, can then interactively be clicked not only to show the different documents which are relevant here, but also how they combine together in this topic and how the top 30 words of these topics are, how frequent they are, and which words they are, to still manually check whether this automatic topic labeling was reasonable or not. A third visualization was the geographical visualization. So when you see that here a large cluster of things happening in Europe, we just had to zoom out a lot to also show that something is happening in the US as well. Sorry. Because one of the most problematic things when visualizing what is relevant where was that publishing until 1900 happened in only a handful of major cities in the world where the publishers were located. So it was possible to really see the difference between different regions, especially if you look into only the German-speaking countries, you don't have that many publishers in different cities. Therefore, we took instead the birthplaces of the authors and used those for geographically visualizing where certain topics were how frequent at certain points in time. I mentioned the usability tests before. So in the end, we had 5 language teachers participating. So we know these are not like overly representative numbers, but overall, they were really content with the performance of the thing, resulting in an average SUS score of 90. In particular, you can see here that the thing the language teachers struggled the most with were generating new types of graphs, whereas modifying them was the easiest task and super easy to handle. And also working with the word clouds and the trend graphs wasn't an issue for most people. So to wrap this all up, our project was meant to empower learning based on project-based learning methods. We also wanted to include into this project as empowerment and different sources of feedback for the students, teachers of different fields. So not only data science and artificial intelligence, usability, web development, but also language teachers to show them very different perspectives on the same topic, which they technically worked on, to help them gain an insight of what is relevant for different user groups, what is making their work important, and how this is also appreciated by the people they actually wanted to design it for, providing them with an intrinsic motivation. We ended up with an interactive web app, which the students developed with clear guidance in this project, which provided different graphical representations, such as the scatter plots in the topic model field graph, the interactive bar plots, and the geographical maps. Overall, we saw that it was a very positive and fruitful collaboration. Language teachers truly appreciated it and provided a lot of good feedback, which also resulted in very good usability scores from our testers. Therefore, I want to thank you for your attention. And yeah, I'm sorry you cannot actually ask questions here, but if you feel like asking questions, just write us an email, please. Thank you, and see you at some other conference soon.